Good morning, everyone. Today, I report about data communications. But before that, let me introduce first myself. I am Marvin A. Acerit, BSIT 2B. My report is all about data communications. So, what is data communications? Data communications refers to the transmissions between two or more devices or computers. It is the way to exchange informations between the user and the computers. Example of data communications is phone callings. That is one of the example of data communications. And data communications gives you the ability to stay connected with others using phone callings, instant messagings, emails, and social network sites. We have 5 characteristics of effective communications. First, it uses the same transmission medium and language. For example, your teacher is going to meet you through Google Meet, then you are using Zoom, then you cannot connect with each other. The point is that if what he or she using, example, Google Meet, then you must use Google Meet in order to connect with each other. And of course, in order to understand with each other, you must use the language that they understand too, which is English. The second is direct and indirect communications. For my own examples, the direct communications is face-to-face communications, even through online like video calls, through Google Meet, and through Zoom and etc. While the indirect communications is like instant messaging and through emails and through voice emails through messengers. Next is mutual understanding. For example, if you know that your receiver is an unmute person, then to convey your message to his or her, you should act your message, which is using sign language. Or your receiver is a foreigner, then he or she could not understand a Tagalog language, then you, as a sender, you are using a Tagalog language, then think the way that he understand you, which is by using a universal language, which is English. Next is a continuous process. It means you have nothing interruption with your meeting. That is a continuous process. And the last is the use of words as well as symbols. For example, your receiver is an unmute person, then you must use a sign language for her to understand you. Even if your receiver is a foreigner, then you should use this universal language to understand you, which is the English. Okay. Data. So what is data? It refers to information presented in whatever form is agreed upon by the parties creating and using the data. These data informations may be in a form of text, documents, images, videos, audio clips, and etc. And we have 3 fundamental characteristics of data communication. First is the delivery. The system must deliver the data into the correct destinations. So it means the data must be delivered by the intended device or users. And next is accuracy. It means the data should or must deliver it accurately. Timeliness. The system should or must deliver it the data in a timely manner. So it means in the data communications, time is very important in any aspect of communicating. Then we have 5 components of data communications: the message, sender, receiver, medium, and a protocol. First is the message. This is the informations or data to be communicated. It can be form of text, numbers, images, sounds, or videos, or any combinations of these. Sender. It is the person, devices, or computers that generates to send the message. Receiver. A person, devices, or computers that receive the message from the sender. Medium. It is the channel or a physical path through which the message is carried from the sender to the receiver. And the last is a protocol. It is a rule which is both sender and receiver should send protocols to communicate or interact with each other. Then we have a data presentations. First is the text. Text can be letters or words to generate a message for your receiver. Then we have a ASCII. ASCII is stand for American Standard Code for Information Interchange. It is used for electronic communications. EASCII stand for Extended American Standard Code for Information Interchange. It means encoding are 8-bit or a larger encoding included the 7-bit character. That's what we call EASCII. Unicode. It provides a unique number for every character, no matter what platform, device, applications, or language you used. The numbers, image, audio, and video. This is our ingredients to generate or to form a message for our receiver. Then we have a data flow. First is the simplex. It is a communications in which data can only transmitted in a one direction. So for my example, me as a sender, I send a message from my receiver, but my receiver could not give feedback to me. That's what we call a transmitted in a one-way directions, like the radio broadcasting, computers and keyboard connections, and the television's broadcasting. And next is a half duplex. Each station can both transmit and receive, but not at the same time. For example, a computer A and a computer B. The computer A send a message to the computer B, and the computer B can give a feedback to the computer A, but not twice. And the last is a full duplex. Both stations can transmit and receive simultaneously. For example, we have a computer A and a computer B. Both this computer can transmit and receive concurrent. Then we have a three network criteria. First is the performance. It can be measured by transmit and response time. The performance of network depends on the number of a user. The transit time. It is the amount of time that required for the message to travel from one device to another. And the response time, it is the elapsed time between an inquiry and a response. Reliability. It is measured by the frequency of the failure, time it takes a link to recover from failure, and the network's robustness in a catastrophe. Security. It is how the network protect the data from the unauthorized access or unauthorized users. Then we have the categories of network. Network is categories with the following factors: the size, ownership, distance it covers, and physical architecture. The categories are the local area network, or what we call LAN, metropolitan area network, or MAN, and wide area network, or the WAN. As we can see, the first categories is the local area network, or the LAN. The size of the LAN is a building or campus, and the ownership is a privately owned or privately sectors, and the distance is the few kilometers, it is just nearby by the schools or a building, and the physical architecture is the bus, star, and a ring. An example is that laboratory network in ISU Kawayan campus, the CCSICT department. The computer laboratory is just like an example of a LAN, local area network. And the next is the metropolitan network. The size of the metropolitan network is the city. In Kawayan City, if they have a metropolitan network, so whole Kawayan are connected in this network, and the ownership is the public company or a government. And the distance is the extent entire city. Just like what I said earlier, it is whole city. For example, in Kawayan, whole Kawayan. So the physical architecture is the LAN to LAN. And the example of this is the cable network. And the last is the WAN. The size of the WAN is a globe. And the ownership is private or a public. And the distance of WAN is extend over entire globe. And the physical architecture is the man-to-man. And the example is internet. In WAN, as long as you are connected in internet, that's what we call a MAN. It is wide area network. Next, we have the network. It consists of two or more computers that are linked in order to share resources such as printers and CDs. The network may be linked through cables, telephone lines, radio waves, satellites, infrared light, or etc. The LAN, MAN, and a WAN is the best example of a network. In mid-1960s, a standalone devices. Mainframe computers become more common in large industries. In that year, they introduced the PDP-1, which is the first mini computers. The ARPA, which stands Advanced Research Project Agency, is an arm of the U.S. Defense Department that funded the development of the ARPANET in the late 1960s. And the DoD, Departments of Defense, it is a federal department responsible for safeguarding national security system. So it is created in 1947. The Association for Computing Machinery, it is an educational computing society. The ARPA to ARPANET is a full advanced research project agency network. It's an experimental computer network that was the forerunner of the internet. The interface message processor was the packet switching node used to interconnect participants' networks to the ARPANET from the late 1960s to 1987. In 1969, these four universities were connected to use the packet switching in that year. Vint Cerf is the father of the internet. In the year 1972, Vint Cerf and Bavcan is invented the TCP and the Transmission Control Protocol and the IP, or what we call Internet Protocol. The physical topology is the way you to physically lay out to the internet, like the map. And we have four categories of topology. The first is the mesh, bus, star, and a ring. The mesh is a local network topology in which all the infrastructure nodes are connected directly. The bus is a network topology in which all nodes are directly connected to a common half-duplex link like bus. A host on a bus is called a stations, in which stations will receive all the network traffic, and the traffic generated by each stations has equal transmissions priority. The bus topology is like the local area network or the LAN, in which all the nodes are connected to a single cable. The star topologies are used in many networks, large and even small. In a star topology, all nodes are indirectly connected to each other through one or more switches. And it is an implementation of a spoke hub distributions paradigm in a computer networks. So that's what we call star topology or star network. And the last is the ring network topology. In a ring topology, each node connects to exactly two or others nodes, forming a single continuous pathway for singles through each nodes or a ring. And that's the end of my presentations. Thank you for listening. I hope you enjoy my presentations. I hope you learn a lot and gain more knowledge about my discussions about data communications, the fundamental of effective communications, about the network, about the ARPANET, and the physical topology. Thank you.